This recording is for section 2.1. In this section we're going to talk about trig functions in terms of acute angles. Instead of looking at them as angles in a plane, we're just going to look at the trig functions as functions of an acute angle in a right triangle. So when we talked about an angle in the plane, we had our right triangle picture that we created using the XY. So we had the X and the Y and the R. If we take this out of the plane and just draw it as a right triangle, then we have our angle here, which we're calling angle A. The side that we called X here, we're going to call that the side adjacent to angle A. Y that's over here, we're going to call that the side opposite to A, because if you look at the triangle, it's opposite the angle A. And then this value, which we had as R, it's the hypotenuse of the triangle, so we're going to call that the hypotenuse. So when we're looking at trig functions based on right triangles, instead of using the X, the Y, and the R, we're using the adjacent side, the opposite side, and the hypotenuse. So in this figure, this side of length Y is called the side opposite angle A. The side X is called the side adjacent to angle A. So that gives us another way to define our 6 trig functions. So before, when we talked about the sine of an angle, we defined it as y over r. Now we're going to define it as the opposite over the hypotenuse. For the cosine, instead of x over r, we're going to call that adjacent over hypotenuse. And for the tangent, y over x would be the same as opposite over adjacent. Now I'm not going to worry about filling in these functions on this side because they're all just the reciprocals of these ones over here. If you can remember these 3, then you just have to remember which ones are reciprocals to get the other 3. Now there's a memory trick for this, and to do that we use the first letters of the function and then the 2 sides. So for sine, we've got S for sine, O for opposite, and H for hypotenuse. For cosine, we've got C for cosine, A for adjacent, and H for hypotenuse. And then for tangent, we've got T for tangent, O for opposite, and A for adjacent. So our memory trick for this is so, ka, toa. So if you can remember so, ka, toa, then that gives you those definitions based on the right triangle. Let's do an example. So based on this right triangle, we're going to find the sine, cosine, and tangent values for both angle A and angle B. And which side is the opposite and which side is the adjacent depends on which of these 2 angles we're looking at. So let's start with angle A. So for angle A, the side opposite angle A is 7. So I'm going to abbreviate opposite as OPP. The side adjacent to angle A, one right next to it, is 24. And the hypotenuse is 25. So from that, we could find the values of these 3 trig functions. So this would say that sine of A, it's opposite over hypotenuse, so that would be 7 over 25. Cosine of A is adjacent over hypotenuse, so that would be 24 over 25. And tangent of A is opposite over adjacent, so that would be 7 over 24. Now, if we want to look at angle B, we have to go back and figure out the opposite and the adjacent sides. So the side opposite angle B is this one. So our opposite is 24. The side adjacent to angle B is the 7. and the hypotenuse is still 25. The hypotenuse is always the same, no matter which angle you're looking at. So this time, if we're finding the sine of b, opposite over hypotenuse is going to be 24 over 25. For the cosine of b, that's adjacent over hypotenuse, which is 7 over 25. And the tangent of b is opposite over adjacent, which is 24 over 7. Now, if you look at the values that we ended up with, notice that the sine and cosine values are just switched in this one. And also notice, since we had a right triangle, that the A and the B are complementary angles. And because of what happens when we look at A and B, what we do is switch the opposite and the adjacent. That means the sine and the cosine are always going to be switched if we're looking at two complementary angles. So this gives us what we call cofunctions. Remember, when we write the actual names of the functions out, we've got sine and cosine. For this one, we're just putting a co on the front of it, so that means that these two are what we call cofunctions. The same way with secant and cosecant. So these two are cofunctions. And we have the same thing with tangent and cotangent. So these two are cofunctions. What it means when we have two functions that are cofunctions is that their values for complementary angles are going to be the same. So for instance, in this right triangle, if we look at A over C, for angle A, the side A would be the opposite. So A over C would be opposite over hypotenuse. That means that would be the sine of A. If we look at angle B, though, the side A is the adjacent side. So A over C would be adjacent over hypotenuse, which would be the cosine of B. So it's just switching from sine to cosine when we switch from the angle to its complementary angle. If we look at A over B in this triangle, that doesn't involve the hypotenuse, which means it would be the tangent. It would be the tangent of A because side A is opposite angle A. So A over B would be the tangent of A. But if we look at angle B, then A over B would be the adjacent over the opposite. That would be the reciprocal of tangent, so it would be cotangent. So again, we're switching from the function to its cofunction when we switch from the angle to its complement. And then last of all, if we're looking at C over B in this triangle, that's hypotenuse over one of the other two sides. So that would either have to be secant or cosecant. If we're looking at angle A, the B is the adjacent, so that would be the secant of A. If we're looking at angle B, the B would be the opposite, so that would be the cosecant of B. Another way that we can think about this is to write these out as identities, and this is just saying what we were talking about up here, that we're using the complementary angle. This is saying that if we have the sine of A, then the cosine of its complement is going to be equal to that. We're finding the complement by taking 90 degrees minus A. And the same thing for all the rest of these. Notice in all of these we've got the function and its cofunction. So sine and cosine, cosine and sine. Then we've got secant and cosecant. And here we have tangent and cotangent. Let's try to use this to write functions in terms of their cofunctions. What that means is that we're going to change from the function to its cofunction, and we're also going to change from the angle to its complementary angle. But one way to do this is just pick out the identity that looks like this to start with. So we're here where we have cosine of 52, we're going to use this identity right here because that starts with cosine. So now I'm going to just put in 52 degrees instead of my A. And over here, I'm also going to substitute 52 degrees for the A. If I go ahead and subtract here, that's going to give me 38 degrees. So the cosine of 52 degrees is equal to the sine of 38 degrees. I can do the same thing here. First, I'm going to pick out the identity that has tangent of A on the left side, so that would be this one. Then I'm going to substitute in 71 degrees for angle A on both sides of this. Oops, 71 degrees. And if I go ahead and subtract that, that's going to give me cotangent of 19 degrees. Same for this one. The identity that starts with secant is this one. And I'm substituting in the 24 degrees for the A. And if I subtract those two, I get 66 degrees. Secant of 24 degrees is equal to the cosecant of 66 degrees. Let's do one more example that involves these identities. In this one, we're actually trying to solve this equation. So what we're trying to find here is a value for theta. So what I would do is go back to our identities, find the one that looks like this. So that would be this one up here. What this tells me is that my A is going to be theta plus 4 degrees. And then if I look at this side, I've got 3 theta plus 2 degrees, and that needs to be the same as 90 degrees minus A. So really I'm just writing out two different equations here. Now I've got two equations and I actually have two variables because I have the A and the theta. So what I can do is substitute. I already have this one solved for A, so I can substitute this into this equation in place of the A. That would give me 90 minus the quantity theta plus 4 degrees equals 3 theta plus 2 degrees. Then I'm just going to solve this for theta. So I'm going to distribute my minus sign. That gives me 90 minus theta minus 4. I can simplify on this side. That gives me 86 minus theta. I'm going to add theta to both sides. Then subtract 2 from each side. And then finally I can divide both sides by 4. So that's going to give me theta equals 21 degrees.